welcome to the Microprocessor and Microcontroller lecture series. In this lecture, we are going to see the functions of CPU and some important terms used in this microprocessor. Okay, this topic comes into the introduction of microprocessor. Why? We are going to see this introduction of the microprocessor in these last two lectures. The basic aim of this lecture to reach the basics of the microprocessor to the students. Before that, we are creating the interest to the student, then only everybody can understand this topic in easiest way. That's why this introduction to B is a basic of these lectures. Okay, clear? In this function of the CPU and some important terms. In previous lecture, we discussed about the how the CPU can be developed, how the processor can be developed from the Intel 4002 Core i7. All this comes under the microprocessor. In this lecture, how the CPU can be work, the function of the CPU. It's not cover the whole function, it's some basic function I will teach here. Okay, clear? First, definition of the microprocessor. The microprocessor is a programmable device. Okay, that takes in number, perform the arithmetic and logical operation according to the program stored in the memory and then produce the other number as a result. Clear? The microprocessor is the programmable device. Simply it says that microprocessor is a programmable device. It can perform arithmetic and logical operation according to the program. Clear? It can, the number is in a form of, in a microprocessor, this number is in a form of zeros and ones. Okay, next, how the microprocessor or CPU fit in this motherboard. This is a motherboard structure. Clear? In this motherboard structure, in the center part, that is the heart of the, this is the heart of the motherboard or heart of the CPU. Here this CPU is contained the microprocessor, already I taught here. Here this is the RAM circuit. Everybody is computer. Just open your computer. Just look at here. This is the motherboard. This is the heart of the computer. This motherboard is have the processor. Is above the processor some heatsink is there. If you are removing the heatsink, under that one the microprocessor or CPU is there. Okay. Then is connected to the RAM. Okay. RAM in the sense is the random access memory. This microprocessor to be connected to the, this is the input output devices. Your keyboard, your mouse and your monitor, your printer can be connected to this input output interfaces. Okay, clear? This is the motherboard structure. This is the Intel CPU motherboard structure. Here I choose only the 8-bit of microprocessor here. That's why this address bus is 8 and data bus is also 8. The address bus is 8 and data bus is 8. Okay, clear? Next, how the CPU can work. Inside the CPU, okay, what are the components are available? What are the functional block diagrams are available? First, the main functional block diagram of the CPU is, the first one is microprocessor. It can perform the all operation. Next, this is the memory element. Next, this is the input and output devices. The input devices in the sense, the keyboard, okay, microphone and your mouse, these are the some input devices as like that. Okay, next, what is the output devices? Output devices in the sense, the TV monitor, printer, speaker, these are the output devices to be connected to your computer. Okay, next is the memory element. In the memory element in the sense, the CPU has a memory element. There are two types of memory is there. One is a primary memory, another one is a secondary memory. The primary memory in the sense, it has the random access memory or read-only memory. Random access memory, read-only memory. Everybody is known what is random access memory. The random access memory in the sense, it can read and write operation. It can perform the read and write operation. The read-only memory means, that is ROM means, it can only perform in the read operation, not for the write operation. Clear? In the secondary memory, in the sense, it is a external hard disk we are using in your computer. Okay, external hard disk we are using in your computer. This is a secondary memory. In upcoming lecture, I say memory in the sense, your mind is directly striking to the primary memory, not in the secondary memory. In this full lecture, we are going to concentrate, or our instruction deliver is only on the primary memory. In the primary memory is divided, already I told that there are two types. One is the RAM, another one is the ROM. Random access memory, it is a very important memory for this microprocessor. Okay, this is a random access memory. Clear? Everybody is understand? Okay, no problem. Okay, random access memory. Next, how the random access memory data can be stored. We will discuss in upcoming slides. Before that, I want to tell one thing to you. Okay, this microprocessor is directly connected to the memory and the input output device. This input output device and memory is not connected directly. Is connected through only the microprocessor. Clear? This input output device not connected directly to the memory. It connected through only the microprocessor. Okay, clear? This is the simple CPU. Next, what are the instruction cycle to be performed here? The first one is the fetching. Fetching in the sense data from the memory. Simple, it says data from the memory. Now, what is the function of the memory? Memory in the sense it is a register. It can store data. Is only storing the data? No, it is only the program is also. I will give some examples. Now we are going to open your computer. I want to open the Microsoft Office. This Microsoft Office is a program. This program is also stored in the memory. Okay. In this Microsoft Office, I type my content in one paragraph or some letters or some content I typed here. This content is a data. Okay. This both program and content to be stored in this memory. Okay. This is the random access memory. It to be stored in the memory. Okay. Whenever you want the data, whenever you want the program, first our instruction is goes to the microprocessor. Then this microprocessor giving the instruction to the memory. Then the data or program can be fetching from the memory. This is the fetching. Next one is the decoding. What is by decoding? We are discussing upcoming slide. The final one is the execute. Next, in this memory, how data can be stored? Everybody's mind has a lot of questions. How the data to be stored? The data in the sense it can be converted into binary, it to be stored in the memory. We are going to record one audio signal. This audio signal is directly stored in this memory? No. Then how to store the audio signal? The audio signal is first converted into the digital, then the digital information, that is the binary signal, only stored in this memory. Okay, clear? Next, I take a picture by using the digital camera. Okay, or our web camera. I take a picture by using our web camera. My picture has a lot of colors. How the picture is directly stored in the memory? No. How the memory can store the picture? First, I want to say simple example. In this picture, it contains a lot of pixel. Everybody is known. What is the quality of the camera? 24 megapixel, 12 megapixel, 3 megapixel, like that. Okay, that much amount of pixel can be in a single image. If you are capturing your image, this image is contain that much amount of pixel. If our pixel rate can be increased, the quality of image is also increased. If your pixel rate can increase, the size of the image also increase. But here I consider this one picture. Okay, this picture contains lot of pixel like that. Each pixel have different color. For example, the single picture it has a red color. Okay, I will take one pixel from here. This is the pixel from this image. This color is the red color. How to represent this red color in binary form? Okay, already we know that the red color, the color in the sense we are using the RGB color, red, green, blue. Okay, in this representation, how it can represent? It is F. It is represented by the R, and this is F. This is the green. This is for blue, as like that. Okay. Now my color is red color. Okay, my color is red color. How the data can be stored? How the image pixel can be stored? Here red color means only this is the red color. That's why this term only represented by the FF, others are the 000. Clear? This is the pure red color. This is the pure red color. This is the hexadecimal representation. It can convert it into the binary form. F is equal to 1111 and another F is equal to 111 and 0 is equal to 000 and 0000 and 0000. This is the red color representation. If you are the maroon color, it can represented by the different form. If you are using the green color, the representation is 00FF00. As like your data can be stored into your memory. Your data can store into a memory or your image can be stored in a form of binary signal. How you are going to check? If you are capturing one image, just right click, show you the properties. It shows 24 kilobyte, 3 megabyte. Okay, this is the size of the memory. In the sense, that much amount of bit can be accommodated in this single picture. This is the storing of the data. This is the storing of the data in your memory. Okay, next we are going to show how data to be stored in memory. Everybody is using high level language, C, C++, Java. For a simple example I will take here, A equal to B plus C. This is a high level language. If you are adding the two numbers, we are initiate B and C in the integer. Now we are going to add B plus C is equal to A. This is the high level language. In a microprocessor, we are using the assembly level language. It can represent add B comma C. Okay, add B comma C. Both are similar, but this is the high level language. This is the assembly language. This both language is directly support to the your microprocessor or your computer? No. How it can support? Your system only understand the binary number zeros and one. Clear? This language is called low level language or machine level language. Simply say this object or binary. Understand? Your machine only understand the binary number, not for the add B comma C, not understand the A equal to B plus C. Then how your program can be converted? This high level language to be converted into the low level language, that means machine level language, we are using the compiler. Compiler in the sense, in students' mind, you strike that the compiler is there. It is used to execute the program? No. It is used to identify the error? No. The compiler in that sense, it can convert high level language into the low level language. The compiler in the sense, it can convert. The simple answer of the compiler is the high level language to be converted into the low level language. It is in the form of the binary number. As like the assembly level language to be converted into, the assembly level language can be converted into low level language by using the assembler. Assembler can convert it into the binary number. Compiler in the sense, some example, C, Turbo C. This is one of the compiler to convert high level language into the low level language. This binary form of instruction is called as the opcode. Clear? This binary form of instruction is called as the opcode. Next, how the decoding can work. I want to tell one thing. If you ask the students what is meant by decoding, immediately they are tell that decoding is the convert decimal number into binary or any digit into binary. No. Decoding in a microprocessor is understanding of the opcode. Opcode, what is meaning of the opcode? Opcode is the binary number. Understand of the opcode. This is the decoding. The decoding of the microprocessor is understanding of the opcode. Simply I say this is the understanding of the opcode. How it can be understand the opcode? Now we are going to consider this is the memory element. This memory element is contain the program as well as the data. Okay, program as well as the data. This is the I will consider as the here I consider as the 2-bit memory element. This we can store the program in a form of 00, 01, 10 and 00. These are the opcode. This is the opcode. Now we are going to understand the 00 means. In machine level language, the 00 is a add in a assembly level language. 0 1 means a subtract, 1 0 is the multiplication, 1 1 is a division. This is a small example I will take here. Okay, 0 0 is the add. Now in a memory element, the data can store is only in a form of opcode, is a binary representation. Here we are going to fetching the program from this memory. First step, we are going to fetching the program from this memory. Now this 0 0 is come to this 2:4 decoder. This 2:4 decoder is only understanding of the opcode. The 0 0 means this is the addition operation. 0 1 means this is subtraction operation. 1 0 means multiplication operation. 0 0 means again the addition operation. Now we are going to take 0 0 from this memory to the microprocessor. The microprocessor can understand the opcode. If you are receiving the 0 0, then it immediately said that we are going to perform the addition operation. This is called as the decoding, understanding of the decoding. Here this is the fetching, this is the decoding performed here. Then finally we are executing the program. Clear? Our fetching in the sense we are going to take the data or program from the memory, and the microprocessor can understand the opcode is a decoding, and execution can be take place in the microprocessor. Finally the output to be displayed in any one of the display. Clear? This is the decoding. Next, this is the fetching. Next, decoding. Next is the execution. Next, this is the concept of the binary and hexadecimal number. Why the data can be represented by the hexadecimal? This is a simple concept we are going to see here. Okay. First we are going to take the decimal number. The decimal number is varies from 0 to 9. We are going to increase above that. It is at 10. But the binary number, the 4-bit binary number, it changes from 0000 to 1111. But is a 9 means it's a 1001. It can stop here because of in a 10 mean it can be represented by the 2-digit. Okay, it is not possible in this microprocessor representation. That's why we can go for the hexadecimal representation. In the hexadecimal representation, the binary number is changes from 0040 to 41. The total combination is 16. How it can be represented in the hexadecimal? The 0 is represented by 0, 1, 1, 2, 2, 3, 3 and up to 9. The 10, it can be represented by the A. 11, it can be represented by B. And 12, it can be represented by C. And 13, it can be represented by D. And 14, it can be represented by E. And 15, it can be represented by F. Okay, therefore, we are using the hexadecimal number in your microprocessor applications. Whenever we are converting the binary number into hexadecimal, we are using like that. Okay, why we can use for hexadecimal number instead of the decimal number? If you are using the decimal number, it can be represented 9999. It can store only the 10,000 information only. If you are using the hexadecimal number, it can represent F. F is in the sense is a 15. Okay, it can store 65,535 information in the 4-digit representation. Therefore, it can store more information in less space. Okay, both are using the same space, but hexadecimal giving more information. Okay, next. In computer, we cannot use the decimal system. In a computer, we cannot use a decimal system, but we are showing in your keyboard, it is only a decimal system and some letters are there, but it not represented by the decimal system. In a machine language, it can only by using the binary number, but in our microprocessor system, we are using the hexadecimal number. Okay, clear? Next, some example. Now we are going to take the 8-bit number. 00 means is a hexadecimal representation. Each digit it can be represented by the 4-bit. Clear? Each digit of the hexadecimal number can be represented by the 4 bit 00 in the sense 00000000. Next 1a means 1 and 10 equivalent to 10. A is equivalent to 10. 1010. 35 means 30011 is 3. 5 is in 0101. 74 that means 7 next 4. 93 next FF. The simple way to calculate the binary number is, everybody is learning this digital subject, 8421. Now we are going to represent 9. 9 in the sense 8 plus 1, this is 9. Next 8 plus 2 is a 10. Now we are going to represent the 13. 13 means 8 plus 4 12 plus 1 is a 13. This is for 10, this is for 9. We are representing by we are going to represent 7. 7 in the sense 0 4 plus 6 plus 1 7. Okay, clear. This is a simple way to represent the binary number. Finding the binary number. Now we are going to find the 16-bit number. Okay, it can represent by the 4 digit of hexadecimal number is 00. This is 16-bit 129 1 2 9 A B35 A B35 C74EH C74H and D930. As like that, we are going to convert our hexadecimal number into binary form. Our system is only understanding the binary representation, not for the hexadecimal representation, not for the decimal representation. In our simplification, by using our simple calculation, we are using only the hexadecimal number. Okay, clear?
Here, we are going to see the terms using microprocessor. A digit of binary number is called as a bit. Okay, the 4-bit binary number is called as the nipple. The 8-bit binary number is byte, and the 16-bit binary number is var. And 32-bit binary number is double var. And 64, 128, and 256, 512. This is called as the multiple var. Okay. Next, this is the power of 2. This power of 2, it is used to represent the capacity of the memory element. Now we are going to see the 2 power 0 is equal to 1, 2 power 1 is equal to 2, 2 power 2 is equal to 4, 2 power 3 is equal to 8, 2 power 4 is equal to 16, and 2 power 5 is equal to 32, 2 power 6 is equal to 64, 2 power 7 is equal to 128, and 2 power 8 is equal to 256. 2 power 9 is equal to 512, and 2 power 10 and 2 power 10 is 1024. Literally, it is says that it is 1 kilo. 2 power 10 is 1 kilobyte, and 2 power 11 is 2 kilobyte. 2 power 12 is 1 megabyte. 2 power 30 is 1 gigabyte, and 2 power 40 is 1 terabyte, and 2 power 42 is 4 terabyte. Now my question is, what is the 2 power 16 is equal to what? 2 power 16, how to write this 2 power 16? 2 power 6 into 2 power 10. Already we know that 2 power 6 is equal to 64 into 1 kilobyte. This is equal to 64 kilobyte. This is the representation of the memory element. This is the representation of the memory element. One more question now here, 2 power 24. Here how to write this one? 2 power 4 into 2 power 20. 2 power 4 is equal to 16 into 2 power 20 is equal to 1 mega. How to write this equation? 16 megabyte. Okay, this is the representation of the memory element in the microprocessor.
Thank you.